Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson 5 on slopes and negative numbers. Now up to this point in time, right, we've been working with equations of lines, especially like lines that pass through the origin, right, proportional relationships. And in the last lesson, we also looked at lines that then didn't pass through the origin and we started to see ones and talk about things like the y-intercept of the line. But one thing that the line has always done is it's always risen as you go from left to right. And that's a positive slope. But there's absolutely no reason why the slope, which is a number, remember, right? The slope's a number, why that number can't be negative. So what we're going to do today is explore how negative numbers kind of get involved in slopes and what they will tell us about the movement of the line. So let's jump right into it right away. And see a line that's got a negative slope. Now the slope of a line does represent how steep it is, or maybe I should say the absolute value of the slope, now that we could have a negative slope, represents how steep it is. But the slope can be negative, which will have an effect on the line's direction. So let's take a look at exercise number 1. Consider the line whose equation is -1/2 times x plus 7. Letter A, fill in the following table and graph the line. Awesome. So let's do it. And let's fill in a little bit of it together and then we'll have you fill in the rest of it on your own. All right, so our favorite point to start with, x equals 0, right? And again, we're producing the y coordinates. So I'm going to have -1/2 times 0 plus 7. Now I don't care what number you're multiplying by 0, the result is 0. So I'm going to get 0 plus 7, and that's going to give me 7. And I'm going to plot that point right away, 0, 7, as we talked about in the last lesson. That is my y-intercept. All right, now let's put in x equals 2. All right, and here's where it's really important for us to kind of step back and discuss this a bit. I want you to never forget that if you have a negative number, -1/2, times a positive number, +2, the result is a negative. A negative times a positive is a negative. And of course, a negative times a negative is a positive. But in this case, when I have -1/2 times +2, my result is -1, right? Because if I had 1/2 times 2, that would be 1. But -1/2 times 2 is -1. So that's going to give me -1 plus 7. That -1 and a little bit of the 7 are going to cancel to give me 6. That gives me the point 2, 6. That's going to be right here, right? Let's keep going. Let's do one more of them together and then have you do the last two on your own. I'll have -1/2 times 4 plus 7. -1/2 times 4 is going to be -2 plus 7, and -2 plus 7 is +5. So that gives me the point 4, 5. You probably already see where the pattern's going, but I'd like you to finish off the XY table, plot the points, connect them with a straight line, and then we'll discuss. Take a few minutes. All right, let's do it. Let me just kind of bring this down here a little bit. I'll have -1/2 times 6 plus 7. Uh-oh, there's my plus sign. -1/2 times 6 is -3 plus 7. Little cancellation there gives me 4. So I'll have the point 6, 4. All right, finally, if I put 8 in there, -1/2 times 8 plus 7, -1/2 times 8 is -4. -4 plus 7 is +3. So I'll have the point 8, 3. Let me now connect to those with a nice straight line. There we go, good enough. And again, we're really kind of looking at a ray here instead of a line, but we're going to change that eventually in this lesson. But there we have it. Okay, now this is the first time we've kind of seen a line that does this. And in fact, let's get into it in letter B. What happens to the value of the y-coordinate on the line when the x-coordinate increases by 2 units? All right, this is critically important, right? So, let's say I take these 2 points, right? When the x increases by 2 units, now the y doesn't increase, the y decreases by 1 unit, right? And that keeps happening. When x increases by 2, y decreases by 1. X increases by 2, y decreases by 1. So, the answer, what happens to the y coordinate on the line when the x coordinate increases by 2? It decreases by 1. All right. Now, how can we kind of see that in the slope? Well, right, the slope, as we know, is negative 1/2. But how do we see that decreases by 1 by increases by 2 kind of thing? Well, letter C says, write the slope as a ratio of the change in y to the change in x, keeping the denominator positive. All right, so a little review again, right? A negative divided by a negative is a positive. A positive divided by a positive is a positive. But anytime we kind of mix the two signs, we get a negative. And that means the slope, which is negative 1/2, can actually be thought of as negative 1 divided by positive 2. So here's that increase in x, and here is that decrease in y. So we can literally now kind of think of a positive number as being an increase in that variable, and a negative number as being a decrease. So if I write the number negative 1/2 as negative 1 divided by positive 2, then I can see why for every 2 units that x increases, we get 1 unit that y decreases. And that's the effect of a negative slope. Literally, a negative slope then makes a line look like it goes downhill as you move from left to right along the graph paper, right? If I were starting at this y-intercept and I was on a sled, the sled would go downhill. I mean, I don't know too much about sleds going uphill, but all the lines we've seen so far have all had positive slopes. They've gone up from the y-intercept. A slope with a negative slope, a line with a negative slope will go downhill. Let's kind of summarize that. Right? When the slope of a line is negative, it forces the y values to decrease as the x values increase. And this makes the line appear to go downhill when looking at the graph from left to right. Always read a graph like you read a piece of paper, from left to right. So in this case, right, where we have a positive slope, the line moves upwards as we go from left to right. And for a negative slope, the line moves downwards as we go from left to right. Again, very, very important idea when thinking about slope. So let's play around with this a little bit more. Exercise number 2. For each of the following lines, write its slope as the ratio of a negative to a positive. Then graph the line in its slope, using its slope and its y-intercept. So one of the pieces of good news today is that the y-intercept is still just the number that's kind of added on at the end. So that doesn't change. Now, on the other hand, let's take a look at letter A, right? The slope is simply the number negative 3/4, right? But we can write that by literally putting the negative just in the numerator, right? And what that's going to tell me is that I'm going to go to the right 4, right? I'm going to go to the right 4, and then I'm going to go down 3. What am I going to start with? Well, I'm going to still start with a y-intercept, or begin with a y-intercept of 6. But it's still pretty easy, right? Here's my y-intercept of 6. Okay. I'm going to go to the right 4 units, and I'm going to go down 3 units. I'm going to go to the right 4 units, and I'm going to go down 3 units. And that is now going to put me with a line that looks like this. There we go. Right? Now, let's take a look at letter B, right? Actually, what I'd like you to do now is try to do letter B on your own. You know, we've done quite a bit of graphing of lines, even lines that have y-intercepts. Granted, this is the first time we've had negative slopes, but take a shot at it. See what you can do. All right, so again, I want to think about that slope of -2, and I can really think about it as -2 divided by +1, telling me that I'm going to go to the right 1 unit, and I'm going to go down 2 units. Where am I going to start? I'm going to start at a beginning value of 10. So, easy enough, let me just move my ruler out of the way. I start here at 10, I go to the right 1 unit, down 2 units, right 1 unit, down 2 units, right 1 unit, down 2 units. That will be enough to really kind of get me my line. Rotate, and there we have it. Bye-bye, ruler. All right, I should really label these things with their equations. This one is y equals -3/4 x plus 6, and this one is y equals -2x plus 10. All right, so obviously lines can have negative slopes as well as positive slopes. The big difference is with negative slopes, the line is always going to head downhill from its y-intercept. Okay? Let's keep playing around with this. So let's kind of summarize, right? Slope measures two things. You know, at first I just said, hey, slope is a measurement of steepness. And it certainly is, especially when you just look at its absolute value. And by that meaning that you just kind of wipe out any negatives that are there, okay? And then it's just about the size of the slope. So a bigger slope means a steeper line. But it also tells us the direction. In other words, a positive slope means that the line is going to be going up as we move from left to right. And a negative slope means that the line is going to be going down as we move from left to right. And you can almost think about it in perspective of where you are from the y-intercept, right? Are you on the y-intercept and you're walking up a hill? That's a positive slope. Or do you start at the y-intercept and slide down a hill on a sled? Then that's a negative slope. Remember that we can kind of like show those changes by using that small little triangle, which is really the Greek letter delta, and it stands for change in. And it's kind of important for you to get used to actually that word delta, because you'll hear teachers, a lot of math teachers, because it's just easy to say, they'll say, oh, the slope, it's delta y divided by delta x, or change in y over change in x. And sometimes we'll even call it the rise of the line divided by the run of the line. The run being the horizontal movement, and the rise, that's a lot easier, being the vertical movement. It's always good when you think about slope to really at first think about the delta x as being positive, and then the question is the delta y positive, in which case the slope is a positive number, or is the change in y negative, in which case the slope is a negative number. Let's see how this plays out again, but now with a full grid. Let's see the full grid and maybe actually have the problem on the page. Exercise number 3. Consider the line y equals -2/3 times x plus 4. Okay, now letter A asks us, why are the fractions -2 divided by 3 and 2 divided by -3 both equivalent to the fraction -2/3? Think about that for a moment. This is rather important. Pause the video if you need to. All right. Well, again, critically important that you recognize that this fraction, and this fraction are all the same number. All right. And it's pretty simple. It might be a little bit wordy, but it's pretty simple, right? In the first fraction, you have a negative divided by a positive, and the result is a negative. In the second fraction, you have a positive divided by a negative, and the result is a negative, right? So maybe we can just summarize by saying, in both cases, the division involves both a positive and negative, so the result is negative. So why even bring this up? Why not just, all right, it's just negative 2/3. Well, we bring it up because they kind of lend to two different interpretations, right? So if I see a slope of negative 2/3, I can either think of that slope as being negative 2 divided by positive 3, or I can think about it as positive 2 divided by negative 3, and that leads us to question B. Interpret both slopes in terms of changes in x and y below. Well, okay, so in this case, right, when we look at this and we know that the 3 is the change in x and the negative 2 is the change in y, well, this basically means, right, increase x by 3 and we decrease y by 2, right? On the other hand, this one, right, this one would be decrease x by 3 and increase y by 2. So, just to be very clear, right, a positive number represents an increase, a negative number represents a decrease. So I can either think of the slope as being, okay, I'm increasing x by 3, decreasing y by 2, or I'm decreasing x by 3 and increasing y by 2, which is odd because one would think then that those two different interpretations would give completely different lines or graphs of lines, and yet they don't. And let's take a look at that in letter C. Graph and label the line using the y-intercept and the two descriptions of the slope in B. All right, so let's talk about that. Let's kind of get into it, right? Our y-intercept is 4. That's easy enough. Let's just plot it. All right, there's our y-intercept of 4. Simple enough. Now let's say that we were interpreting the slope this way, right? What we would now do is, starting at our y-intercept of 4, we're going to go 3 units to the right, increasing x by 3, and we're going to go 2 units down, decrease y by 2. So what will that do? It will kind of, there's 3, 2 puts me right there. 3, 2 puts me right there. 3, 2 puts me right there. All right? So that's kind of interpreting it this way. But now if I interpret it this way, decrease x by 3, increase y by 2, that does the following. Here's decrease x by 3, increase y by 2. Decrease x by 3, increase y by 2. Decrease x by 3, increase y by 2. And what we should see at this point is that, in fact, all of those points now, every single one of them, lie on that nice straight line. Oh man, that did not work the way I thought it was going to. All right, I'm not going to try to erase that line and get it to go through all the points. Most of the time that thing should just digitally make a straight line. It didn't that time. Technology, gotta love it, gotta hate it when it doesn't work. Anyway, but the point is, what's really cool about this interpretation of slope is that it really gets into that whole negative divided by a positive, positive divided by a negative, still gives you the same result. It's just in one case you're kind of moving this way along the line, and in the other case you're moving this way along the line, and it gets that line that extends infinitely in the two directions. Isn't that kind of awesome? All by just recognizing that negative 2 divided by 3 and 2 divided by negative 3 are both equal to negative 2/3. All right, let's take a look at another situation. Exercise number 4. Consider the line y equals 4/3 x, 4/3 times x, minus 5, which has a positive slope of 4/3. Letter A, given the two equal slopes below, give interpretations of each in terms of changes in x and y. All right, so let's back out just for a second and make sure we get something, right? I'm sure for nobody is it a problem to say that the slope's 4/3, so we're going to interpret this slope in a moment. But make sure you understand that 4/3 and negative 4 divided by negative 3 would be the same thing, right? Be the same thing because a negative divided by a negative is a positive. So these two are actually the same number, but they get different interpretations in terms of slope, right? So in this one, right, what we're thinking about, given that this is delta x and this is delta y, or the change in x and the change in y, is that if we increase x by 3, we're going to increase y by 4. On the other hand, over here, where my change in x is a negative 3 and my change in y is a negative 4, here, if I decrease x by 3, I'm going to decrease y by 4. Okay, and both of those are perfectly valid interpretations. Now, don't get me wrong, if you saw 4 divided by 3, or 4/3, and you only think of it in this way, that makes a lot of sense. This feels like it's like extra work. But we're going to see again how this plays out exactly like this does on the grid. But there is one more thing that's a bit unusual about this line, right? We're really used to lines where we've got a number added on at the end, and that number added on at the end is the y-intercept. Here I have a number subtracted. So what's going on with that? Well, let's take a look in letter B. What is the y-intercept of the line? Use this and the slopes to graph the line on the grid above. And actually, for us, the grid is down here. For you on your worksheet, the grid is up above, but for us, it's kind of down below because it's going to be easier for you to see that on the screen. All right, well, keep in mind that if I have a line that has this form, y equals m times x plus b, then the m is the slope and this is the y-intercept. But for us, the line is y equals 4/3 x minus 5. So it doesn't quite fit that, right? Because it's not plus a number. But remember, we can always take a subtraction and turn it into an addition of a negative number. So really, y equals 4/3 x minus 5 can be thought of as y equals 4/3 x plus negative 5, right? Subtracting 5 and adding a negative 5 are exactly the same thing, which means that my y-intercept is negative 5. And that's the first time we've definitely seen that. So let's do it. Let's plot that y-intercept down here at negative 5. Now, we had two interpretations of slope, and I'm going to see if I can get them just a little bit more in the screen, right? One of them was, increase x by 3, increase y by 4. That one's easy, right? So, we just move this out of the way. I increase x by 3, increase y by 4. I'm right here. Increase x by 3, increase y by 4. 1, 2, 3, 4. Great. Increase x by 3, increase y by 4. And I'm right here. Right? And that's this interpretation of slope, right? Positive 4 divided by positive 3. But we could also have negative 4 divided by negative 3, and that would say, right, let me extend this a little bit. That would say, all right, well, I'm going to decrease x by, sorry, I overshot, decrease x by 3, decrease y by 4. And if I had more graph grid, I would decrease x by 3, decrease y by 4, etc. The key is that these points down here will fall in that pattern, right? Thus creating a nice straight line that will hopefully actually graph out as straight this time, or at least graph out as a line. Let's see if it actually works. Oh, yes. That time my ruler worked. Hate it when rulers don't work. And there is that line, right? And again, what's really cool about it is that we can have negative y-intercepts. That's okay. It just means there's going to be a number subtracted at the end of the equation of our line. And we can then certainly have both positive slopes and negative slopes. We just have to be able to interpret what those slopes mean in terms of the movement along the line. i.e. increase in x, increase in y, increase in x, increase in y, or increase in x, decrease in y, etc. All right, let's wrap this one up. We saw a couple new things today. Yeah, we certainly saw slopes that were negative, but we also in that last exercise saw y-intercepts that were negative. The key though, really, more importantly than a negative y-intercept is a negative slope. And this idea that if the slope of a line is negative, then what's going to happen is that line is going to go downhill from the y-intercept, right? As we read the graph from left to right, the line's going to go downhill as opposed to the line going uphill from left to right. All right. Now, having a negative y-intercept is simply just having a number subtracted at the end, because we can always rephrase that subtraction of a number as adding the negative version of the number, therefore putting us below the x-axis to start, right? And you could see that. You could see maybe some kind of linear function that's predicting a temperature, let's say, and maybe the temperature starts at -5 degrees, and then it's increasing in some way, maybe as time progresses, something like that. All right, we're going to get a lot more practice graphing lines, both with negative and positive slopes and with negative and positive y-intercepts. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.